Hi, my name is Abbye. Today we'll be going over the developmental networks. Developmental networks are genetic pathways that have regulators to determine if a specific phenotype will be produced. Specifically, this pathway where the phenotype is the production of spikes in a certain cells of the ectoderm of the spiny beetle. The arrows indicate that the gene stimulates transcription of the gene in front of it, and the dashed line means that the produced gene inhibits the transcription of the gene in front of it. The S gene, if produced, will then stimulate the transcription of the P gene, and the produced P gene will then stimulate the I gene. I will not stimulate, though. If it is produced, then it will inhibit the transcription of the K gene, which will in turn have the ability to inhibit the E gene. In this particular network, E is the gene that needs to be produced to create spikes in the beetle. Without the production of the E gene, there will be no spikes. Say there was a mutation that stopped the transcription of the P gene. This would inhibit the transcription activity of the I gene. Without an I gene to repress the transcription of the K gene, K can then inhibit E and there will not be any spikes produced. But if there was a mutation in the I gene that stopped its production, then it would not be able to inhibit the K gene. With K fully functional and transcribed, it will inhibit the transcription of E, and in turn there will be no spikes. Let's say I and E are mutated, so they are not produced. No spikes are produced with this mutation. As shown before, without the I gene, ultimately there wouldn't be any spikes produced because the K gene would inhibit transcription of the E gene. But in this scenario, there wasn't an E gene to begin with, so no spikes. This last mutation involves S and K gene. If the K is not transcribed, then there is nothing to inhibit the transcription of E. If S is not transcribed, then there is nothing to stimulate the production of P, and in turn nothing to stimulate I, which could not inhibit K. But because there is a mutation in K that stops its production, E is produced, so there are spikes. Every cell in the ectoderm cannot have spikes. If they did, there could be spikes everywhere on the beetle, which would really harm the beetle. There are more likely epigenetic tags on each cell of the DNA that choose not to produce the spike gene.